Alright, so now that we've talked about one-dimensional conservation of momentum, let's try to introduce two dimensions. This is going to be just like our kinematics, where when we introduced a new dimension, all we did was consider the x and y components. And that's all we have to do here. So, let's say that we have a system where we have a ball that's maybe 3 kilograms, and it's motionless, and then we have another ball that's maybe 6 kilograms, and it's traveling towards this ball at 10 meters per second, 30 degrees from the horizontal. Right, so 30 degrees from the horizontal, I just mean we're 30 degrees away from this horizontal line. Alright, so then, in our final state, we find out that this ball travels to the east, due east, and this ball, the 6 kilogram ball, travels due north. Can we find the velocities at which they'll travel? I'll label this as v3 prime and v6 prime. Do I know what the velocities are yet? No, I'm just labeling this 3 and 6 to correspond with the masses, because that's all we know about the balls. Alright, so how do we do this? Well, I'm going to say this horizontal thing is going to be my x, and this vertical is going to be my y, and we know these are perpendicular because east and north are perpendicular. Okay, so now what I can do is I just consider the initial momentum that's in the x direction in this system. Well, do I have any initial momentum from this ball in the x direction? No, I have zero momentum because it's not moving, right? Zero velocity means zero momentum, right? And then this in the x component, this would be the component, this would be the component, right? So if this is 30 degrees, right, because this is 30 degrees by alternating interior angles, this is 30 degrees, so we know that this is just going to be cosine 30 times whatever this is, 10 meters per second. So we say this, our velocity in the x direction of the 6 kilogram mass is equal to 10 meters per second times cosine of 30 degrees. And this one is on the opposite side of the angle, right? So we'll say this is the Vy direction 6, which is equal to 10 meters per second times sine of 30. So right now we're only considering the x one, so I'm just going to use this one here. So I need the mass. So to find the momentum of this in the x direction, I take the mass, so 6 kilograms, multiplied by the velocity, which is 10 meters per second times cosine 30, so that's 5 root 3 when I evaluate it. And yeah, so my momentum in the x direction initially is just 30 root 3 kilogram meters per second, or I can just say Newton seconds. Alright, so now let's find in the y direction. Well, again, this one contributes nothing because it's not moving. But this one contributes this velocity times this mass, which is 6 kilograms, right, times 10 sine 30, that's 10 times 1/2, which is equal to 5 meters per second. So this whole thing evaluates to 30 Newton seconds in the y direction. Alright, so now let's calculate the things here. Our final momentum in the x direction is equal to this velocity times this mass, right, so 3 kg, forgot the g, times v3 prime, right, final velocity. And this one contributes nothing because there's no component in the x direction. But here, for the y direction, this contributes everything, right? So we have 6 kilograms mass times our velocity. But this one doesn't contribute anything because there's nothing in the y direction. By conservation of momentum, this is equal to this. Initial in the x is initial in the y, initial in the x is final in the x, and initial in the y is final in the y. So we set these values to be equal, and what do we get? Well, here, if we set these two to be equal, we get px, which is 30 root 3 Newton seconds, is equal to p prime x, which is 3 kilograms v3 prime. So if I divide both sides by 3 kilograms, I get v3 prime is equal to 10 root 3 meters per second. Similarly, I do that with this, and I get 30, right? 30 Newton seconds is equal to 6 kg times v6 prime. So v6 prime is equal to 5 meters per second. And there we go. We've solved it. This velocity is 10 root 3 meters per second. This velocity, the vertical one, is 5 meters per second. we can conceptually check this because we started with more momentum in the x direction, right? And we do end with more momentum in the x direction because even though this mass is doubled, this velocity is more than double this mass. So we still end up with more momentum in the x direction. So yeah, again, conservation of momentum, all you have to do is you set the initial momentum equal to the final momentum, and you're able to solve for different things. Yeah, there we go. And next video, we'll talk about how we can use conservation of momentum with another law, the conservation of energy, in order to find some interesting things about these about collisions. All right, have fun.